All right, this video is going to be on multiplying and dividing rational expressions. So first, I just want to remind you guys how to multiply fractions. So if we had the fraction 2 over x multiplied by y over 5, the way that we multiply fractions is we just go straight across. So 2 times y is 2y, x times 5 is 5x. So with multiplying, you just multiply straight across. All right, so here are a couple of examples. Example 1, we're going to go ahead and do 3x divided by 5 times 30 divided by 18x squared. So when we do this problem, since we are multiplying straight across, we're basically going to end up with 3x times 30 over 5 times 18x squared. And you can multiply that. You can say 3x times 30 is 90x, and 5 times 18 is whatever that ends up being. But it's a little bit easier with these problems if you reduce before you continue to multiply. So when we reduce, that means that we have some fractions that can simplify. So for instance, 30 and 5 both have a factor of 5 in them. So I could say 30 divided by 5 is 6, and then I could say 5 divided by 5 is 1. And so that makes the problem a little bit easier to multiply now. I could look at the 3 and the 18, and I could say, oh, 3 and 18 both have a common factor of 3, so I could say 3 divided by 3 is 1, and 18 divided by 3 is 6. Okay, so at this point I have 6x on the top and 6x squared on the bottom. So now I could say, oh, the 6's would divide to equal 1, and then there's an x on bottom and an x on top and 2 x's on bottom, so I could say that one of these will cancel with one of those, and so my result is 1 over x. Now you could have got that if you started at the very beginning, so this would have been 90x over 90x squared, and it just kind of depends on how comfortable you are with your numbers getting large like that. So I like to reduce as I go because then I get to deal with smaller numbers at the end. Doesn't matter, it's up to you. All right, let's do another example. So that was pretty easy. It was a monomial divided by a monomial multiplied by another monomial divided by a monomial. So these are always a little bit more difficult when we start having binomials or trinomials because the factoring gets a little bit more complicated. So let's say we had x squared minus 3x minus 10 over x squared plus 8x plus 15. And we could be multiplying that by x squared plus 2x minus 15 over x squared plus 9x plus 14. And so here we know that since we're going to multiply straight across, we can kind of write this as like one big fraction. And so I'm going to walk myself through those steps that we learned about when we were simplifying rational expressions. So I'm just going to write this as one big fraction. And on the top, I've got two numbers that multiply at a negative 10 but add to negative 3, and so that would be negative 5 and 2. So I have x minus 5 and x plus 2. And then for the bottom right there, I have multiplies to 15, adds to 8, so that's 5 and 3. So x plus 5, x plus 3. And then over here I have two things that multiply to negative 15 but add to 2. So that would be 5 and negative 3. So x plus 5, x minus 3. And then I have two numbers that multiply to 14 but add to 9. So that's 7 and 2. X plus 7, x plus 2. Okay, so I can go ahead and anything that would divide to equal 1 can cancel. So I have an x plus 5 and an x plus 5. And again, they don't have to be right on top of each other because I know this is all the same. This is all the top of the fraction and the bottom of the fraction. And so multiplying and dividing do cancel out. So the x plus 5's cancel, the x plus 2's cancel. I have an x plus 3 and an x minus 3, so those are not going to cancel. So I'm left with x minus 5, x minus 3, over x plus 3, x plus 7. So this right here is a great answer. It is also possible if you were doing a multiple choice problem, like if you're doing a test for me, that answer is fine. But it's possible that on a multiple choice problem, they would have FOILed that back out. And so if they did FOIL it back out, that would be x squared minus 8x plus 15 over x squared plus 10x plus 21. It is possible that they could do polynomial long division with that. I don't know that they would, but it's possible. So you could try long dividing it if you would like. Okay, so the big thing to remember is that with multiplying, we always multiply straight across. And then once we have done that multiply straight across, then we can do our kind of factoring and canceling with the tops and the bottoms. Okay, so next we're going to go ahead and remind ourselves about dividing. So if we had 2 over x divided by y over 5, we would actually rewrite the problem as 2 over x. You might have heard this called keep it, and then multiply instead of divide. So keep it, change it, and then the last one as flip it. So if you have one fraction divided by another fraction, you keep the first fraction and then you multiply by the reciprocal. So keep it, change it, flip it. And at this point, we just turned it into a multiplication problem, and so we're going to multiply straight across. So 10 over xy. Okay. It is also possible to see the problem written as 2 over x divided by y over 5. And some teachers would still say keep it, change it, flip it, or some teachers might have said multiply by the reciprocal, so multiply by 5 over y. So I've seen it said a few different ways. Keep it, change it, flip it is typically how I say it because multiply by the reciprocal sounds really wordy. I've also seen some teachers do this. And so they say that's 10 over xy. That one's not my favorite because I think that I would have mixed them up. So, but whichever way you have learned it before, keep it, change it, flip it, multiply by the reciprocal, or if you learned this method, all of them work the same. So you just have to let me know how you want me to phrase it for you so that you're comfortable. All right, so we're going to go ahead and do one more example problem, just doing a division problem to make sure that we can handle all of those steps in there. So we're going to do x squared minus 1 over 4x divided by x squared minus 5x plus 4 over x to the third minus 16x. Okay, so first I'm going to do keep it, change it, flip it. So I'm going to change this to multiply, and then I have the reciprocal over here. And then I do have some factoring to do. So for this first fraction, I have difference of squares, so that gives me x plus 1, x minus 1. Over here, I can factor that GCF of x out, so that leaves me with x times x squared minus 16. And when you look at that, you can actually see that that is difference of squares as well. So I'm going to go ahead and erase that and just fix it right now. So x squared minus 16 is x plus 4, x minus 4. And then for the last one, we're looking for two numbers that multiply to positive 4 but add to negative 5. And so that's negative 4 and negative 1. So x minus 4, x minus 1. And so I can say my x minus 1's cancel, my x minus 4's cancel. I have a plain x and a plain x that cancel. And so for this, I would have x plus 1 times x plus 4 over 4, and that's a good answer. So it's possible that they would have that written down as the multiple choice answer, or you could FOIL the top back out and say that's x squared plus 5x plus 4 divided by 4. I could see it going either way, and those are both good answers.